everyone. A cylindrical can is to be made to hold 1 liter of oil. We're going to find the dimensions that will minimize the cost of the metal to manufacture the can. So we're going to draw a little picture. Here's your cylinder. All right. And then if we look at the bases, if you do the area of the circle, that's pi r squared. We have 2 of them, so the total area is going to be 2 pi r. And for the surface area, the area of this part in here is going to be the area equals 2 pi r times your height. This is, I don't know if you can tell, this is like the outer part of the cylinder. I did my best. So anyway, you add the areas up, and the area is going to be 2 pi r squared plus, so that's the top and the bottom of the circles here, and then plus the area of the circular part in between, and that's going to be plus 2 pi r h. Now, the problem gives us that it's made to hold 1 liter. So to solve this, what we want to do is we're going to take 1 liter equals 1,000 centimeters cubed. So what we can do is we can write pi r squared h equals 1,000 and solve for h. So h would be 1,000 divided by pi r squared. Now, we're going to go ahead and substitute our h into this h right here, and then differentiate to minimize. So we're going to minimize the cost of the metal to manufacture the can. So we'll do that. We're going to write this as area equals 2 pi r squared plus 2 pi r, and we solved for h, so we can take the derivative, because our r is like your what we're differentiating. So we have 1,000 divided by pi r squared. Now this part, these two will cancel. You'll just have an r underneath, and then we'll have 2 times 1,000. So our area is going to be 2 pi r squared plus 2,000 divided by r. Now, let's go ahead and we want to minimize this. Remember, r has to be positive and greater than 0. It can't be 0. So we're going to find the critical numbers. A prime of r equals, differentiate that, that's going to be 4 pi r. And then we have, when you differentiate this, we can write this as 2,000 r to the negative 1. And so that's going to be negative 1 times 2,000 r to the negative 2. So basically what you're going to get is minus 2,000. Let's put that there. 2,000 divided by r squared. And to have our common denominator, if I want an r squared here, I'm going to have to multiply the numerator by r squared. So a prime of r is going to be 4 times pi r cubed minus 500 divided by r squared. So I just multiplied those two to get me the common denominator. And now we want to set this to 0. And when we set it to 0 and solve for r, let's do that. So we're going to have, Let me duplicate page. So we're going to have pi r cubed minus 500 equals 0. And to solve for r, you add 500 to both sides. Divide by pi. And then cube root both sides. And this is your only critical number. So our domain has to be from 0 to infinity for a. It can't be less. But we need to observe that, so this is r equals this. We have to observe that a prime of r is negative when r is less than cube root of 500 divided by pi. And also, a prime r is positive when r is greater than cube root of 500 divided by pi. So that means if it's both negative here, both positive here, that's this one. So that means f prime of c, or in our case f prime of r, is the absolute minimum. So a is decreasing for all r to the left of the critical values. So to the left, this is decreasing. And we're using the first derivative test for absolute extreme values. And this is kind of something new. What we've been using is the first derivative test, but that only applies to local max and min. So we're using this information for our absolute extreme values. All right. So it's increasing for r to the right. This is increasing. Decreasing for r to the left. So it's going to be an absolute minimum. It's this one right here, because it follows this pattern B. Now, so that way what we're going to do is now find our thing. The value of h corresponding to r equals cube root of 500 divided by pi is h equals 1000 divided by pi r squared. So that's going to give you 1000 divided by pi. Here's your r. So plug that in. And that's going to be 500 pi. And it's squared, but it's the cube root. So I'm going to just write to the 2/3. So this is going to equal 2 cube root of 500 divided by pi, because that cancels out. All right, and this is approximately equal to 5.42. So that means that, and this right here also equals 2r. So all that means is the height should equal to twice the radius, which is the diameter. So this equals your diameter. All right, and that's it. Thank you. Have a nice day. Bye-bye.